Expression for time taken by the pulse to reach the top of the rope. We are seeing a string is suspended, otherwise a rope is suspended from the rigid support like this. The total length of the rope is say L. So this is the total length of the rope. The mass per unit length of the rope is mu. This is nothing but what? This is mass of the rope divided by the length of the rope. This is the meaning of mass per unit length. Otherwise, how much will be the mass of the rope of 1 meter? That is mass per unit length. Now, if you are given a pulse like this at the bottom, so if you give a pulse like this here, okay, so here is a pulse. So this pulse will rise up and it may reach the top like this at this point. At this moment, we will simply consider a small segment. This is of width dx. Okay, so width dx. So now the arbitrary length of this elemental length is say x from the bottom to this point. Now which is equivalent to, this is equivalent to is kind of mass which is of a certain value. Okay, so this much. So what should be the tension at this point? That should be found first, right? So tension at this point. So this is nothing but what you are seeing here is nothing but this one is the equivalent mass of the rope of length x. Okay, so of length x. Therefore, this mass is equal to what I can write. I can simply write mu into x. This is the mass of this portion. So whose weight is acting downward, and the weight is written like it is mu x into g. This is weight. Now the tension which is acting at this point, mass, right? So is T, and this T is equal to the magnitude of the weight, which is equals to mu x into g. So this is the tension at this point. Now the speed of the wave at this point, right? The speed of the wave at that point is the instantaneous speed. That can be found like this, V is equal to root of tension divided by mu. So further, this V is equal to root of what I can write, tension is mu x into g divided by mu. Otherwise, this V is equal to, the speed is equal to root of xg. Okay, so this much. This is the speed of the pulse, at that point. Say this point is say some p. Okay, so p, so point p. So at that point the speed of the pulse is this much, and which is moving upward. Okay, so you can observe as x increase, this value of x, the consideration of length from the bottom, if we take it more and more, the speed increases. So it is not constant. So now the instantaneous speed is this much, right? Is the instantaneous speed. Instantaneous speed, right? Instantaneous speed. So how actually we define this instantaneous speed? The instantaneous speed is dx by dt, right? So this is the time taken to cross the rope of length dx. So now we do it further. That is V is equal to, right? V is equal to what I can write, dx divided by dt can be written like this. v is this much, which is root of x into g, right? So which implies what I can write, which is dt is equal to, it is dx divided by v, otherwise I can write dx divided by root of xg. Now the total time taken by the pulse to reach from bottom to top is t is equals, okay, integration of dt, which is equals to integration of dx divided by root of x into g, right? So x is the variable which is taken from x is equals 0 to x is equals L. So x is equals 0 at this bottom and x is equals to L at the top. So now if we do this, we will get t is equals, okay, so t is equals, now what we may get, it is nothing but 2 times, right, 2 times the root of x divided by this g from the limit x is equals to 0 to x is equals to L. Okay, when you put the limits for this x, definitely will get 2 to root of it is L divided by g. So this is the value of time taken by the pulse to reach from bottom of the rope to the top of the rope, okay, so which will be 2 times root of L divided by g.